So in the first part of this velocity lab, our objective was basically just to simply calculate the toy car's constant velocity. And we did that by running the toy car across 4 meters and then clocking it at checkpoints of 1 meter. So there were 4 checkpoints, obviously. So once we got our data points, I went to the graph here and I basically plotted distance in meters over the time in seconds, because time is always the x value because it's dependent on the meters in this case. And so once I got these 4 data points here, I free-handed a line of best fit, similar to what we did in the last lab. And then, of course, in order to find the slope, I tried to pick, again, 2 points that crossed evenly with my graph paper. So I chose this point here and just this point here. So this point here, in order to find the change in distance, so this dotted line here, I went over here, which is 4.75, minus all the way down here, which is 3.25. Subtract it out, your change in distance is 1.5 meters. And I did the same thing for the x values. So I went here, which is 11 seconds, minus 7.5 seconds, subtracted 3.5 seconds. So similar to what you would do in a slope of a line, change the change in y over the change in x, but in this case it's the change in distance over the change in time. Do it on a calculator, 1.5 meters divided by 3.5 seconds, 0.43 meters per second. Now, meters per second could be a unit for velocity, basically a rate of how far the car traveled over a certain amount of time. You traveled this many meters over this many seconds. So this number ends up being the velocity that our toy car went in this lab. So there we go. We were able to answer the objective just by finding the slope of this line of best fit. You know, that this number is the car's velocity. So now that we were able to find the objective, there were definitely, I can analyze some of the possible sources of error in this lab. One of them being that probably the main reason was that our toy car, as it moved along the 4 meters, tended to lean to the left the farther it went. And, you know, since we were trying to keep it on path, we used our feet every time we would pass by the checkpoint just to keep it in line. However, it could have done one of two things. It either could have sped up the car when it wasn't supposed to, like it gave it a little, it kind of made it go a little faster than it was supposed to, or it could have done the opposite and actually slowed it down when it wasn't supposed to, which could then affect the time, the end time that it reached after 4 meters. Also, since we had, our group was a little smaller, we had one person clock for efficiency, we had one person clock 2 different checkpoints. So it's possible that there could have been some delay when managing the stopwatch, but that probably wasn't as significant. And then with my graph, again, I free-handed this line of best fit, so there could be some questions as to whether or not this is actually as accurate as it could be. I remember that you told me the accepted velocity was 0.47, 0.48, so this is just a little bit under it, but it's still pretty accurate. So definitely we were able to get a good value for the velocity, and we were able to successfully answer this objective and, you know, perform the lab adequately.